Here's another photoelectric effect experiment. So we've set up an experiment as below: light source, filter, so to make sure we've got certain colours, which hits the metal plate here. The electrons absorb the photons, and some of them are ejected, collected here, and we can measure a voltage and a current. Right, so this is selenium, and here is the maximum kinetic energy that the electrons that are given off have. So basically this is the voltage measured at the voltmeter for this as you change the frequency, as you change the colour. Right, the first question asked us, the students double the intensity of the light source and then they repeat the experiment. So the dotted line is the original intensity. What is the graph of the new intensity? So remember, with the photoelectric effect, if you double the intensity, the voltage will stay the same. So with the intensity change, the energy of electrons is the same, therefore voltage is the same, but the number of electrons changes, therefore the current changes. So let's just go over this. When you change the intensity, the energy of each electron is the same, and so therefore the voltage that you measure is the same, but the number of electrons changes, and therefore the current changes. But this is a graph of the kinetic energy, or the voltage, that we measure out, and it doesn't change. So the answer for this one, D. Alright, now we're using a different metal, a new metal, and that's magnesium instead of selenium, and it's got a different work function, i.e. it takes less energy to get electrons out of this magnesium than it did out of the selenium. So which graph shows us one where the work function is different, and it's down at 3.7. Alright, so the selenium, if you were to extend this graph down here, where it crosses this point here, this is the work function. So that would be 5.1 negative. So the magnesium, if it's going to have 3.7, would be up here somewhere. If you extend that out, it works out that this is graph A. Okay? Nowhere else can, if you extend magnesium down here, this is going to have a bigger work function than selenium. They have the same angle. They have the same gradient. The gradient is Planck's constant, so that doesn't change, so that's why that one is not the correct answer. That's why that one's not the correct answer. And different work function means they have a different intercept down here, so that's not the correct answer as well, so the answer is A.